Cars have been a consumer product since the times of Henry Ford, but Robert Sikorsky never made the helicopter into something that every Sikorsky employee bought. But today, an aircraft is something that is for everybody. Since aircraft are consumerizing, the volume of aircraft, and if you want to think of all these aircraft as part of the national airspace system, the scales are changing by many orders of magnitude. And a lot of what the new stuff is low altitude flight, because these are small airplanes, they're consumer products. They don't fly at 50,000 feet, they fly at 100 feet or 200 feet. So the crux of the research actually flows from there. Suddenly we have a conversation which is very clamorous, and I think what is fundamentally needed to straighten out the whole problem of airspace and make the industry move forward is to structure that conversation. So this is, I think, one of the fundamental aspects of making this problem solvable. Who gets to have a say over what? Not everybody talks about all airspace. The FAA is the only agency that gets to talk about all airspace across the country. But everybody else is structured according to not some new structure that needs to be invented, but according simply to the system of private property and local government that we have all already accepted and understand. So the air parcel idea, that's why it starts with the land parcel map that is well understood in law and extrudes that up and says that if you are going to have a say about any air in this country, it is at best going to be about the air that sits on top up to some altitude that is to be determined through this whole process that we are going through, right, by whatever laws get passed. But this is at most what you have a say over. So that's the basic idea of the air parcel model.
So essentially, at this point in the whole research, we are looking at three kinds of permissions. One is saying that, on an air parcel, you can't really fly. So a consumer can say, oh, this is my parcel, no flight there. Second is saying, oh, you're free to fly completely. I have no inhibitions. Third is rest or partial restriction, which is saying that you have to pay to breach that air parcel. Or maybe, you can only breach that during certain times of the day, right? Now, once you have these permissions for different air parcels next to each other, then when you're trying to do, for example, a package delivery from, a hub to somebody's house, you get these permissions from the system, and then you plan your flight path in a way that it doesn't breach any of these unpermitted spaces. And at the same time, it also calculates, for example, if your shortest path actually needs to go through a space which, let us say, you just have to pay a bit for, then okay, it calculates, the minimum cost of the flight that you want to take. So today we have a prototype website where you can visualize the entire air parcels at different altitudes. You can look at different classes of airspaces and how they kind of overlap or join each other. And you can actually change permissions at different levels of these airspaces.
The air parcel system gives you the brain of the system. But besides the brain, we need another tools. And the first tool is how to identify the drones. Because if a drone is flying over somebody's head and somebody wants to complain about this drone, they need to know who is the pilot, who owns the drone, who is flying that drone, and if the drone has the permission to fly at that time and that spot. So one of the problems we are working with right now is the identification system. We are using an approach differently to create a kind of license plate for drones. So besides putting numbers and letters like the license plate system works right now, we are using color sequence that blinks under the drone in order that any people in the ground just looking up and see the drone will be able to see the color sequence and identify this drone. So we are using some devices that just point to the drone, and this device will capture the color sequence, will translate in the identification of the drone, and do access to the server and check all this information about who is the pilot, what's the route that the drone is flying, who is the owner of the drone, and things like that. We started the first prototype using a cell phone attached to the drone and use the cell phone screen to blink the color sequence. Then we see that it works quite well to test the approach we are going on, but the cell phone screen is not bright enough to be able to see in sunlight. So we went to the second prototype using real LEDs, discrete LEDs, and we built this prototype and we put on a drone, and then we fly outside in the daylight, and we'll be able to see the LEDs blinking by 100 meters. So our next approach is to create a huge array of LEDs under a drone, then to make it be identifiable by 200 meters, 300 meters, pretty much like the car brake lights.
I used to work on the National Automated Highway System project, where our job was to automate America's highways, and we did a big demo in 1997, which actually led to my drone program. And they asked us then, how far are we from reality? We said 5 years. In 1956, when General Motors did an automated highway prototype, it's amazing that they did it. When they asked them, how far are we from reality? They also said 5 years. I think that the more pertinent factor here, right, rather than a technology forecast, is the desire of people. Today, it could even happen next year, or it could happen even 10 years from now. But the reason that it could even happen next year is this time, when the FAA said you cannot do it, there was a huge outcry. Unmanned aviation has a very strong constituency, and these people are not taking no for an answer.